Hello everyone, this is Dr. Vaughn, and I am going to try to help you with homework question 5 and 6 from this week's homework. So here's question 5. I've already kind of taken a look at it and just pre-populated a few things into Excel so that we can get a head start on this video. But I wanted to just kind of call out that what I'm looking at when I go through all of the material up here is, first of all, I notice that the standard deviation that they give me is from the sample. So we don't know the population standard deviation, we know the sample standard deviation. And this tells me that I'm going to need to use a t-test. And the other thing that I'm looking at is the alpha level, which is right here, the 0.10 level of significance. And the last thing that I'm looking at is, are they looking to see whether the sample mean is different than or greater than or less than? So in this case, the question is the population mean cost is less than 3927. So it's this less than that tells me that I'm going to be using a one-tailed test instead of a two-tailed test. And we didn't do one of these in class, so that's why this is a good problem for us to go through. So when we start with the null hypothesis, the first thing I'm going to put is into the alternative, the hypothesis that the population mean is actually less than 3927. The alternative is in essence what we're looking for. We want to suggest that the mean repair cost has gone down. That's stated in the alternative. The null always gets the equal, and then it's the opposite side of whatever the alternative is. So you're looking for the population mean to be less than 3927. The null is that it's not less than 3927. In other words, it's bigger than or equal to 3927. So that's how you type in your null and alternative hypothesis. Notice that what I'm using here is the population mean and not the sample mean. I'm not using the 3860, that's the sample mean. All right, so that got us started. Now the next thing I need to do is find the T statistic. And the T statistic, I'm going to just start to type things into Excel. So I wrote up at the top that this is going to be a one-tailed t-test, just as a reminder. And then I typed in the population mean, the n, the sample mean, the sample standard deviation, and the alpha value. And all of these were stated in the stem of the problem. All right, so now to compute the T statistic, I'm going to find the actual observed value of the sample mean in the same way that we did the z-score kind of conversion. So this T statistic is going to be equal to the difference between the mean and the sample mean. So I'll take equals in the numerator, the mean minus the sample mean. I should actually do the sample mean minus the mean. Sample mean minus the mean. This is going to make it be negative. And then I'm going to divide by the standard error term, which is going to be the standard deviation of the sample divided by the square root of n, because we're looking at the distribution of means. Now you could also take this whole denominator term and write it on a separate column here as the standard error. Okay, so this is my T statistic. I can be a little bit faster because you can always rewind the video to look at this. So my T statistic is negative 1.675. And now it says round to 2 decimal places. So we'll type in negative 1.68. So the next part of this problem wants to find the critical value. Now, this is only going to be one critical value because we're doing a one-tailed test. So the whole idea of the one-tailed test is that 10% error margin that we have, which is the alpha, instead of splitting it into two pieces on the left and on the right, we're going to put all 10% into the left-hand side. So we're only going to have one critical value. There's only one tail that we want to consider. In this case, it's the left tail because we're looking for the sample mean to be below the population mean. We're looking at for it to be less than, right? So we're putting all 10% of the error margin onto the left-hand tail, right? So what I want to do to find this T critical value is to find the associated T distribution, the value of the T distribution where I've accumulated 10% on the left. So I'm going to do the T dot inverse function. I'm not splitting it into two tails. And this time I'm going to use just the whole alpha value. I don't need to split it into two. And then I'm going to put in the degrees of freedom. Now, I should have probably done this before, degrees of freedom in here. But because I didn't, and I just want to be efficient with this video, I'm just going to type in the degrees of freedom here, which is 99. So again, what I probably should have done is added a degrees of freedom and then said equals the n minus 1, and then used the cell reference for the degrees of freedom instead of the just typing in the number. But the t critical value that I get is negative 1.29016. We want that to 2 decimal places as well, so we'll write negative 1.29. Okay, and finally we want to know if we're going to reject the null hypothesis. So the t statistic is negative 1.68, the critical value is negative 1.29. So the t statistic is to the left of the critical value on the negative side. So it is in that big 10% tail. The t statistic is in the tail, and therefore we are in the rejection region. We will reject the null hypothesis, and we will conclude that there is sufficient evidence that the population mean has gone down. It is less than 3927. So the correct answer here is D. Now finally, well not finally, there's probably multiple parts to this question. We're going to find the p-value. So the p-value is where you take this observed t statistic and you turn this back into a percentage. So I'll compute the p-value by using this t statistic and using the t distribution, t.dist, parentheses, and I'll use the t statistic, and I'm going to just use the degrees of freedom, and I'll say cumulative true. And so my observed p-value is 0.048545, and to 3 decimal places, we're going to put 0.049, 0.049. So is this p-value low? So remember our alpha value in this case is 0.10. The p-value of 0.049 is low. The p is low, reject the ho. So we are going to reject the null hypothesis at the 0.10 level of significance. This p-value is the probability that the actual mean cost is at this observed value or below, 3860 or below. The probability of getting a sample mean cost of 3860 or less when the actual mean cost is 3927. Okay, it looks like that was it for this question, number 5. I hope this has been helpful. I'll make a separate video for question number 6.